All right. So I'll give the completed. Okay. So we need to repeat the same thing for lot size. So I'll give you the completed Excel sheet. Okay. So now let's look at log worth. Okay. So for again a given split, we have to set up a frequency distribution like this. Okay. So we are looking at, in this case, a split of less than or equal to 60 and greater than 60, right? So for the left side, how many non-owners we have? Okay. So that would be sum of. Okay, so we already have that somewhere here. So here it is, the number of non-owners for the left side node. Okay, and number of owners for the left side node is right next to it. Okay. Now on the right side node, the number of non-owners is here. Let me copy that. So that's our owner. Okay. So let's look at the total for the row. Okay. And then total for the column. And then of course you have the grand total right here. Now, log worth looks at how, okay, so this cost table, contingency table, how dependent is the rows with respect to the columns. If the prediction, so if these are the predictions and these are the actual values. If there is close relationship between these two, and you will see that, okay, the most extreme case will be, all right, all the non-owners on the left side, okay, on 9, 0, and then all the owners on the right side, so it will be 0, 15. So that will be the most extreme case. Both left side node and the right side node are completely pure, right? So in that case, okay, so that's what we need to compare with. Okay, so if it is, so this is the actual. Okay. Now, the expected frequency, okay, if they are not pure, okay, if the split is not doing us any good at all, okay, so then that's what would be the expected frequency. Expected frequency is given by the row total times the column total divided by the grand total. Okay. Now, if by doing some absolute referencing, we can copy this formula for the rest of the 3 cells. So here, E64, okay, as you copy across the row, the total must always come from column E. And then when you copy down, it should change, the row should change from 64 to 65. So $sign goes in front of E. The opposite is true for C66. You want row to be fixed, column to change from C to D. And for E66, both should be fixed because grand total always will come from E66. So now if you copy that across and down, so you get the expected, and then from this we compute the chi-squared value. So that will be the formula for chi-squared is actual, okay, so the actual value or observed value minus the expected value, okay, and you square that and divide by the expected value. And you need to do this for all the cells. and that will give you the total of that is our chi-squared. Okay. So our chi-squared is the sum of that. Okay. Now we need to find the degrees of freedom to be able to get the log worth. Okay, so we need the p-value. So p-value is r minus 1 times c minus 1. So here the number of rows is 2, number of columns is 2. Okay, we have 2 rows and 2 columns. So degrees of freedom is r minus 1 times c minus 1. Then we can compute the p-value using chi-squared formula. Chi-squared distribution, and we want the right side for chi-squared distribution, and that would be the calculated chi-squared value comma degrees of freedom. So this will give us the p-value, and the log worth is negative log 10. I mean log to the base 10. Negative log of that to the base 10. Or Excel has a log base 10 function. So you can just do minus log 10. So that will be log of base 10. So this is the log worth, and some methodologies use log worth for the purpose of comparing all the various splits that we have, all the candidates for splits. So you can have Gini index, or it can be entropy, or it can be log worth. So like that.